Welcome to the Accenture Innovation Hub in Essen, Germany. In this video, I would like to talk about BIM, Building Information Modeling. That is a methodology that is more and more used during the design, construction, and operation of buildings, production facilities, infrastructure like streets, bridges, water supply, whatever. And we would like to talk a little bit about the theory behind it very, very shortly, and then show how this actually looks like in Autodesk Construction Cloud, in ArcGIS, and in FocusHQ to see how you use it on a daily basis. Let us start a little bit with the theory to give the bigger picture before we show it really. BIM is a method for planning, execution, and operation of structures with a collaborative approach based on a digital structure information model for shared use. I like that definition, but it's probably really hard to understand what this actually means. So first of all, let's start on the first sentence. It's a method. It is not a software. And you are establishing with that a common data structure and collaboration model that is used by different parts of a project or the operation of a building, etc. There's not one single application that is covering BIM. It's usually a combination of many things. So at the bottom, you have here the engineering collaboration platform. This is where your different engineering disciplines will work together, and they will be supervised by project management. Each of these people will work with different specialized software. And this is not one single IT application here that is here established. No, it is simply a similar way of working and using the same data model in all of these applications. So this means a building, for example, has always the same name in all of these applications or collaboration platforms. I have the same attributes like height, width, depth, type of material, whatever, of an equipment, of a wall, of a window, of a pipe, everywhere. So I can rely on having the same definitions in all the applications, and we're all basically speaking the same language. That is the idea behind that. It's not a single IT application, not at all. And in this demonstration, I want to show you now how this actually looks like. And we will first jump into Autodesk, which is an example for an engineering collaboration platform, or sometimes also called as a common data environment, CDE. Then I will show you the exact same information again in a geographic information management, GIS system in ESRI ArcGIS. And then we will also have a look into project management. So what's the view of the project managers of the same project? And last but not least, I will not show it live, but it's basically just a side comment that we also hand over the same information to asset management, which is, for example, an SAP, for the daily operations of the building or facility that we are building here as part of the project. Because this is all a life cycle. Once this has been built, it's moving over to operations. And when it's in operations, it will have to be maintained. And maybe it's later changed or amended or whatever in a new project. And then I'm starting with a project again. So I want to move the same information again in a new project. So it's a life cycle, a circle. And ideally, you use the same data model definitions and the processes along the entire life cycle of that asset. Since I cannot share a client example and also do not want to share you the details of an Accenture office, I am using here a 3D model in Revit that was kindly provided by Deutsche Bahn, German Rail. And this example is a full BIM example, which we can also link in the description. It can be downloaded for free to look into the model, and it has all the metadata for all the equipments and so on with it. And we have used this for the end-to-end demonstration here with the different applications. We now jump into the Common Data Environment, or CDE. In our example, it is Autodesk Construction Cloud. The engineers or external contractors, engineering companies, or whatever I use are often relying on completely different software. They will be using their specialized applications, and I need one common place where all my files, models, but also my workflows and processes and reviews are stored. And Construction Cloud is a very good example for that. The most basic thing is that I have a central file exchange, as I'm showing it here right now, and I will come back to that in a few moments. But a more relevant part is often that you also centralize your communication in one platform. So don't do everything with emails or phone calls. Rather, have a structured way to store these processes. For example, I can create here and manage all my issues in the project here centrally. So I'm creating an issue here, can assign it to people, all my tasks, mitigation actions, and so on are tracked. This is also a good example where we have sometimes overlaps. I will come later to the project management platform, which exactly can do the same. So you make a decision in the beginning of the project, which application do you use? Do you use for issues? Do you use then, for example, Construction Cloud, and then link these issues into your project management solution? Or do I use a project management solution for that? So that's a decision that you need to do in the beginning. So it's not one application covering it all. Sometimes it's overlapping. So then you can also manage your submittals, which is, for example, an official communication that I want to ask someone, please do something, give me a draft, give me something, and then I can define the priorities, assign it to my engineering departments or external companies, and then I can do the entire review process of that, approvals of that here in the application. I can also capture correspondence, meetings, and so on, and so on, and so on. But now go back to the file approach. So one thing that is really important is that you have a common application that that allows everybody to just look at it, even if you don't have the application available. So I don't need Revit here in this case. I can open the model directly in the web application. I have access to the same meta information. I can do a commenting. I can do a further drill down in the model, show me whatever the different elements are. If I would have an issue already tracked here, I could see the issues that are related to it. And I can do commenting and a further drill down of the model for my review processes, so that I don't need to do that on paper or with a different application. All my decisions are captured centrally. As a side aspect of this is, if I have all my models for all the different buildings, or in this case, the rail station, in my database, I can extract this information and consolidate it in lists, like, for example, the lists of assets. This is the list of all the elements you see in the 3D model of the train station as one list with headlines by type. And I can take that, for example, and upload it or synchronize it with my SAP system for later maintenance. And I can take this as my shopping list for my procurement, as an example. And this is the advantage of having then a consolidated platform that can take the data from these different models, different files, different things, and extract it, ideally as much automated as possible. And again, in order to make that work, I need to agree on a common data model, so that my categories here, for example, are the same, that I use ideally the same material codes, catalog items, so that you don't need to do some crazy mapping or so on. It's always the same. This needs rigor and good project management in order to make sure that everybody uses the same data model, but then it makes life so much easier. Now we are changing the perspectives again. We are now in ArcGIS Online from ESRI, which is a geoinformation system to show the exact same data we had before in a different model. This is especially relevant for operations then later, or even during the construction and planning, to have the better context and another way of looking at the data. So we now see the train station with its two sides in the context of the city and on the rail track. And when I go into the model, I can click on anything here, and I see the exact same information that we had earlier in the Revit / Autodesk Construction Cloud model. So for maintenance inspection people that have probably not been there and want to raise something, double check something, this view as a map is fantastic because it allows them to immediately familiarize themselves with the location and work with that. And this is especially relevant during the inspection and operations phase of the project. This is so this is basically a map, and embedded here is the 3D model with different views that I can take. And what we can also do in such a model is, for example, highlighting that there's an issue here. For example, in this case, these red dots above the lamps mean they are broken, and they need to do some repairs to fix them. And I can create forms. This is a very basic view here, but we can create forms in order to do processes again, and then follow up on these in other systems, like, for example, SAP, by building an interface to it from the application here. Now we are moving the perspective again. So we are now in project management or portfolio management. And the example here is the application FocusHQ. It has a broader view than just the design of buildings of the train station, for example. It can also look at the different sub-projects I have. So because maybe the parking lot before that is a different project, and the main train station is another one. They all, of course, have the interdependencies. I might want to consolidate all of my program activities. So, for example, all train stations that I'm building in a certain region, or my portfolios. So I have train stations, I have rail tracks, or whatever. I can combine these different elements and consolidate the information for the different levels of my audience, either internally or externally. And again, here, it is really important that we use the same methodology and data model. I showed earlier that we can also track issues or risks in Autodesk Construction Cloud. And we would then use there, for example, the structure of the assets. So, for example, the building number, the floor, the room, or whatever. So these hierarchies, for example, that we are defining. And I can make the decision that I do the tracking there, or I do it here in FocusHQ, because then it's easier to consolidate these different issues and then report them also to the higher levels, to the portfolio, for example. And again, for that, I need to make sure that I use the same structure and the same data model, because I want then the category and work stream, so on, be in sync with my data model in BIM. Also, I want to make sure that I am using the same schedule. So, for example, a schedule of a project, of course, is sometimes bigger or longer than just the BIM model, because it can start, for example, in the early assessment phase in the invitation to tender. But over time, I'm further detailing down the different elements of the BIM model. And when I'm really in the design phase, I am really deep into information building, information model delivery, where I then have to have the review processes and the deliverables sent out to my different stakeholders, structured according to the same definitions that I have in my engineering systems, for example. So I can track approvals, deliverables, whatever, also here in the solution, with the same data model under one roof here, but coming with data coming from different data sources into this overall view. This ends our short walk through the applications. So allow me to summarize a little bit, again, what I probably said a few times already in the video. BIM is not a software. It's a methodology. It defines a common language, for example, with consistent names, attributes, for all buildings, equipment, or whatever I'm building or designing. It mandates quality through a review and approval process, ideally supported by an application to track everything along the review and approval process in a consistent manner. And also across all disciplines, both internally and externally. The latest information is always uploaded to a common data environment. And this acts as a single source of truth. No more parallel versions of the same things, printouts on some tables somewhere, or distributed file repositories. Please use the common data environment as the single source of truth. And we can use the same data by exporting it, for example, asset lists, and analyze it again and again in a multitude of ways. So every discipline can then take the information they need out of that information. Planners, operations people use the GIS, for example, with a wider context, and they provide a more hands-on information access based on maps and so on. Project managers want to see the progress. Cost controllers want to see what has been purchased, what's been installed, where are we, and so on. So there's a lot of puzzle pieces that we are bringing together, and the more we agree on a very simple data model and same naming conventions everywhere, the easier it is. Again, you cannot fully automate all of this, and you cannot define every single detail of it, but you need to agree on the most common data objects and standards, and that then reduces your time and effort needed for the alignment between people. This avoids rework because you avoid outdated or disconnected documentation. Finally, and that's often forgotten, it then allows a clear and really comprehensive handover of documentation at the end of a life cycle phase. For example, at the end of the construction period, I'm handing over the entire documentation and everything I have to operations and the maintenance guys. They then update it during operations and maintenance. And when there is, for example, a big project coming up to further enhance, review, remodel, whatever, the building or the plant or whatever in scope, I can then do another handover back from operations and maintenance to the project people, and then they don't have to start from scratch. We've shown a lot of software, but again, I want to highlight it several times. This is not software. BIM is not just software. It helps to use software a lot. And it is a process. It cannot be encapsulated in a single piece of software. And the entire information management, the building information management, exists as long as the asset exists and will be accessed by many diverse job roles, many people, both internally and externally. And therefore, please remember that BIM is first and foremost about communication between people, but also between the different software platforms. And the trick here is to fully understand the unique circumstances surrounding an organizational requirements. So you need to agree on a common denominator, make it not too complicated, and identify the key elements that you want to share. And as Accenture, we are, of course, very happy to support you on that. We can help you defining these models, setting up the project organization and the workflows according to that. And last but not least, of course, support you in the implementation and the operations of the applications that you need or want to use for such a project. Thanks very much for watching. There's many more videos available from the Accenture Innovation Hub in Essen. They are available in the links below. And I'm hoping that we will see us there and talk about BIM and other things in the short-term future. Bye.